Hello, welcome to today's lessons on indices. I want to look at an introduction to indices, index notation, plural form of index, that's indices, and the singular form, that's index. And here we'll get to understand that indices tells the number of times a number will be multiplied by itself. So it's talking about power or exponents. Index notation actually is a method of shortening the product of numbers of equal factors or numbers that are the same. Like you can see here, we have some numbers here. 8 raised to the power of 3 is the same thing as saying 8 times 8 times 8, and then 2 raised to the power of 5 is the same thing as saying 2 times 2 times 2 times 2 times 2. That's 2 into 5 places. We multiply 2 into 5 places, and then we have a 4 raised to the power of 2. That's 4 multiplied by 4. We also have here 6 raised to the power of 5, and that gives us 6 multiplied by 6 multiplied by 6 multiplied by 6 multiplied by 6. That's 6 into 5 places. So when we have a number like this, 4 raised to the power of 2 is equals to 4 times 4. 2 is called the power, or we can say index, right? The power or the index, while 4 is called what? The base. 4 is called the base. So there are some laws that govern index notation, and I want to look at the first one. That's a multiplication law. And the multiplication law goes thus: that when numbers with equal bases are being multiplied, their power or indices are added. Like when we have something like this, 3 raised to the power of 2 times 3 raised to the power of 5, right? What we have is 3 raised to the power of 2 plus 5, and that gives us 3 raised to the power of 2 plus 5. That's what? 7, right? 3 raised to the power of 7. That's for the multiplicative law. So what it means is that when numbers with equal bases are being multiplied, their power are added. You can see this number is base 3, but different what? Indices. You can see base 3 raised to the power of 2, 3 raised to the power of 5 gives us 3 raised to the power of 2 plus 5. We also have the division law, that when dividing numbers with equal bases, the power of the divisor is subtracted from that of the dividend. So simply put, we have something like this: 2 raised to the power of 9 divided by 2 raised to the power of 5, right? And that gives us 2 raised to the power of 9 minus 5, and that gives us 2 raised to the power of 4, right? Because 9 minus 5 is 4, isn't it? So generally we can say that y raised to the power of a divided by y raised to the power of b is equal to y raised to the power of a minus b. That's the division law in general. We also have the power law, and in this case we can see an example is given to us here. So if a number which is raised to a certain power is again raised to another power, it is said to be in powers. Like we have here 2, the base number here, raised to the power of 3 in bracket is also raised to another power here too. So the two powers are then multiplied together to get the final result. So what it simply means is we have 2 raised to the power of 3 times 2, 3 times 2, and that gives us what? 3 times 2 is 6, isn't it? So 2 raised to the power of 6. That's what it simply means. Okay, we also have the product's power law, in that when the product of different factors are raised to a certain power, like you have here, perhaps in a bracket, you can see that in a bracket, right? So the power is distributed over each factor in the bracket. So the power is distributed over 3, C, and also B. So what we're trying to say here is we have 3 raised to the power of 2 times C raised to the power of 2 times what? B raised to the power of 2. Also we have, I can also give you another example here. 4A raised to the power of 5 simply means 4 raised to the power of 5 times A raised to the power of A raised to the power of 5. That's A index 5. We also have the 0 index. Here we tend to understand it this way, that when any number or quantity is raised to the power of 0, the result is 1. So what we're simply saying here is when you raise a number or a quantity to the power of 0, the result is what? Is 1. If you say 5 index 0, the result is simply what? 1, okay? And if you even have B index 0, the result is 1. So any number, any quantity raised to the power of 0, the result is simply what? 1. So we can even we can prove that by having something like this. When I say 2 raised to the power of 2 divided by 2 raised to the power of 2 is the same thing as saying 2 raised to the power of 2 minus 2, right? And that gives us 2 raised to the power of 0, which is equals to 1. And then we come to this side. 2 raised to the power of 2 simply means what? 2 raised to the power of 2 all over what? 2 raised to the power of 2, right? That's for this expression here, right, on the left hand side. So what it simply means is 2 times 2, right, all over 2 times 2, isn't it? So 2 would cancel 2 here, 2 will cancel 2 here, 1 1, isn't it? So we have 1 all over 1 here. 2 is 1 1, 1 times 1, 1 times 1, and what we have here is 1 all over 1, which is the same thing as what? 1, right? So you can see we are still saying the same thing here. So we also have the negative index, and for the negative index, the number raised to a negative index equals to the reciprocal raised to the same positive index. Like you can see here, a negative power, that is a negative index of 3 minus 3 here, 2 raised to the power of 3 is something like the reciprocal of this number raised to the same index, but there is no negative here, right? Now you can see no negative, 1 all over this same number but without the negative, such that if you have 4 raised to the power of minus 5, it simply means 1 all over 4 raised to the power of what? Of 5. We have the roots power, where you have a number here raised to the power of 1 over 2, for instance, and that means square root of the base number, the base here, because this is 2 here. Square root is simply this sign here, even though conventionally we do not write the 2 here, but we know that it's square root, there is a 2 there. Unlike if we have something like this, 2 raised to the power of 1 over 3, of course you know it's the same thing as writing cube root of what? Of 2, right? Cube root. Square root, you don't need to write the 2 here, you understand? Cube root, you can see here, and then here 3 raised to the power of 1 over 3 is the same thing as what? Square root of 3. And if we have here, for instance, 3 raised to the power of 1 over 5 is the same thing as saying what? The 5th root of what? 3. Can you see that? The 5th root. So generally speaking, you can say that the power here involves the method of showing the indices for different roots actually. like square roots, cube roots, fourth roots, fifth root like we have here, and it continues on and on and on. The last but not the least is the fraction index, where you can see a base raised to an index which is a fraction, which is not necessarily 1 over 2 or 1 over 3 as we saw in other cases, but this time around you have 4 raised to the power of 3 over 2. So we have our 4 as the base, then the square root sign because of this 1 or 2 which is the denominator here in the power, and then everything is raised to the power of 3. So I can as well say here that this also means 4 raised to the power of 3 over 2 is the same thing also as well. 4 raised to the power of 1 over 2 times then raised to the power of 3. You can see that. So 3 times 1 now is 3 over 2. So now I will take the square root of 4 and raise everything to the power of 3, right? So the same thing applies here. Now for this we have 8 1 over 3 raised to the power of 4, right? So we have cube roots of 8, right? Cube root of 8 and raised to the power of what? 4. You can see the way it goes, right? So I can further simplify this and say, okay, cube root of 8 is what? 2, isn't it? Why? Because 2 times 2 times 2 is equal to what? 8, right? So what I'm simply saying is that 2 raised to the power of 3 is equal to 8, right? So cube root of 8 is what? 2, and that is raised to the power of 4, isn't it? This 4 we have here, you understand? So if you have to still further simplify, it means 2 times 2 times 2 times 2. So 2 times 2 times 2 is 8, then times 2 gives us what? So here I can simply say my answer is what? 16. So in the next video we shall solve a lot of problems involving powers, index, indices, and all of that. So any challenge you will have, I believe we shall explain and break that down in the next video. Thank you for watching.